Hello everyone, in this video lecture we are going to study next shortcut method in which right hand side function is the trigonometric function or the hyperbolic function. So that is the special function. So consider the given differential equation which is the non-homogeneous one of the type phi of d of y is equal to f of x. This is our case 2 where the right hand side function f of x is trigonometric sine ax plus b or the cosine ax plus b, where this a and b they are any constants. We know the general formula for the particular integral, which is yp equal to 1 upon phi of d of f of x. Here it is trigonometric sine function or the cosine function. We will consider now the phi of d, which is d raised to n plus a1 d raised to n minus 1, so on an minus 1 d plus an of y is equal to, here in particular we will consider first the trigonometric sine function sine of x plus b. Now we are going to evaluate terms from this polynomial, the derivatives for the function sine of x plus b. So first derivative will be derivative of sine x plus b of order 1 is equal to a into cos of ax plus b. Second order derivative will be d square sine of x plus b is equal to minus a square sine of ax plus b. Evaluate third order derivative, which will be minus a cube cos of ax plus b. Similarly, fourth order derivative, which will be a raised to 4 sine of ax plus b. Now, just observe all the even order derivatives. So there we are getting some common pattern. What is that? So, see this d raised to 4, fourth order derivative can be rewritten as d square its square sine of x plus b is equal to minus a square its square sine of ax plus b. So if we compare second order derivative and fourth order derivative, we can generalize this and we will be able to write as d square raised to r sine ax plus b is equal to minus a square raised to r sine ax plus b. We will take it to more general form, and that will gives us phi of d square of sine x plus b is equal to phi of minus a square of sine x plus b. Same how we did in the first case, in that way only. Now as we want to obtain the particular integral, so we will operate 1 upon phi of d square operator on both the sides. That will give us 1 upon phi of d square of phi of d square of sine x plus b is equal to 1 upon phi of d square of phi of minus a square into sine of x plus b. So this phi of d square will get cancelled, and we will divide on both the sides by phi of minus of a square, assuming that it is non-zero. So therefore the simplified expression will be 1 upon phi of d square sine of x plus b is equal to 1 upon phi of minus a square sine of x plus b. Means in this case, in the trigonometric sine function, whatever the d square terms are there in the phi of d, the given polynomial in the differential equation, so all that d square we are supposed to replace them by minus of a square, where this a is the coefficient of x under the sine function. So how to get the all d square terms in the phi of d polynomial? We can write d raised to 5 as d into d square its square. D raised to 4 can be written as d square its square. D cube can be written as d into d square, and so on like this. So all such d square terms will be replaced by minus of a square. But Here condition is that provided this denominator should be non-zero. So phi of minus a square should be not equal to 0. Then and only then we can use this rule. Then what happens if this phi of minus a square is equal to 0? So let's see further. If it is 0, then we will proceed as follows. So from the Euler's formula, we will be able to write cos of ax plus b plus I times sin of x plus b is equal to e raised to I of ax plus b. Now consider the left hand side again. So 1 upon phi of d square of sin x plus b is equal to, it is what? It is the imaginary part of 1 upon phi of d square of e raised to I into x plus b. Now we know that in case of exponential function, if the denominator is becoming 0, then how we are evaluating the particular integral? So we will use that rule and it will give us imaginary part of x divided by phi dash of d square e raised to I ax plus b. So this is the case when the denominator is becoming 0 first time, that is phi of d square is equal to 0. So in this way, in case of case failure, we have evaluated the particular integral. Now we will replace this, we will consider the imaginary part of this exponential function, which is x divided by phi dash of d square sine of ax plus b. Now this is again the trigonometric function. So replace this d square by minus of a square using the first rule, just which is which just now we have seen. So that gives us 1 upon phi of d square sine of x plus b is equal to x divided by phi dash of minus a square sine of ax plus b, provided that this denominator should be non-zero. So there are two conditions. First one is that phi of minus a square is equal to 0 and this denominator phi dash of minus a square should not be 0. That is, it should be not equal to 0. Again, if this phi dash of minus a square is equal to 0, then using the same rule, now we can extend it and it will give us 1 upon phi of d square sine of x plus b is equal to x square divided by phi double dash of minus a square sine of x plus b, provided that phi dash of minus a square is equal to 0 and phi double dash of minus a square not equal to 0. Then only we can use this rule. Denominator must be non-zero. So this is all regarding the trigonometric sine function. In same way, we can write down formulae for cosine function and the hyperbolic functions. So we will just list these formulas. So see, 1 upon phi of d square cos of x plus b is equal to 1 upon phi of minus a square cos of ax plus b. That is, again replace d square by minus of a square in case of the trigonometric cosine function, provided the condition is what? This denominator phi of minus a square, it should be non-zero. If it is 0, then the particular integral will be evaluated as 1 upon phi of d square cos of x plus b equal to x divided by phi dash of minus a square cos of ax plus b, provided that this phi of minus a square equal to 0 and this denominator phi dash of minus a square not equal to 0. If it is 0, then we will go to the next case. So this will be the case of failure. Hence we will go to the next case, which is 1 upon phi of d square cos of x plus b equal to x square divided by phi double dash of minus a square cos of ax plus b. Again, as this is the denominator, so it is in denominator, so it must be non-zero. So provided that, what is the condition? Phi dash of minus a square equal to 0 and phi double dash of minus a square not equal to 0. So that is the required condition to use this rule. So this is all about the trigonometric sine and the cosine function. How to obtain the particular integral when right hand side function is the trigonometric sine or the cosine function. Now we will go to the hyperbolic functions. We are going to just see the formulae only. In case of in case of hyperbolic functions, 1 upon phi of d square sine hyperbolic of x plus b is equal to, so in this case the particular integral will be evaluated as 1 upon phi of a square sine hyperbolic of ax plus b. Means we have to replace this d square by the coefficient of x, which is a here, in case of hyperbolic sine function, provided that this denominator should be non-zero. When there is a case of failure, then it will be evaluated as same using the trigonometric, how what we seen in the trigonometric function in same way. So 1 upon phi of d square sine hyperbolic of x plus b is equal to x divided by phi dash of a square sine hyperbolic of ax plus b. So we have to replace d square by a square. But we are going to use this rule when phi of a square is equal to 0 and this phi dash of a square is not equal to 0. Suppose if it is 0, then this will be the case of failure and the particular integral will be evaluated as 1 upon phi of d square sine hyperbolic of ax plus b is equal to x square divided by phi double dash of a square sine hyperbolic of ax plus b. So here we have to replace d square by a square in case of hyperbolic function, provided that the condition is what? Phi dash of a square is equal to 0 and phi double dash of a square is not equal to 0. Then only we are going to use this rule. So this is about the hyperbolic sine function. In same way, we are going to write down formula for hyperbolic cosine function. So see that formula. 1 upon phi of d square cos hyperbolic x plus b is equal to 1 upon phi of a square cos hyperbolic of x plus b, provided that this denominator should not be equal to 0. If it is 0, this will be the case of failure and the particular integral will be evaluated as x divided by phi dash of a square cos hyperbolic of x plus b. Then the conditions are what? Phi of a square equal to 0 and this denominator phi dash of a square should not be equal to 0. If it is 0, again this will be the case of failure. Then we will go to the next case, which is in which the particular integral will be evaluated as x square divided by phi double dash of a square cos hyperbolic of ax plus b, provided that phi dash of a square is equal to 0 and phi double dash of a square not equal to 0. So these are the required conditions. I hope you have understood this, how to use this formulae, that we will see in the next lecture through examples. So thanks for watching this video.